In this video, which I hope to be our final video on geometry, trigonometry, in this video we'll look at sine rule, cosine rule, and bearings, if time permits. So, what is the sine rule? When is the sine rule applied? Where it is applied? Sine rule is used when you're given, or it's applied on not right angle triangles. What works on right angle triangles is the Pythagoras theorem and the trigonometrical ratios. But for other triangles like scalene triangles, isosceles triangles, and probably uh, acute angle triangles and obtuse angle triangles, those triangles we use the sine rule and the cosine rule. So the sine rule is used when given the lengths of two sides and an angle opposite and one angle, and you have to find another angle, or when given the length of one side and two angles, and you have to find another side. And you will see it in these two examples. The sine rule deals with the angle and the side opposite the angle. So I have angle A here, and then I have the length BC, which is common A. So that would be, the sine will be the length A over sine the angle A equal to the length B opposite the length B sine the angle B equal to the length C sine the angle C. Now we don't use all three of these fractions, we use two. We use the fractions that we are interested in. The fraction that has a complete length and the angle opposite it. Length and the angle opposite it. We need that. So we have, in this example here, the length of one side and the angle opposite that length. And we have an angle, and we are asked to calculate this side, which is the side opposite the angle. And so this is E, this is F, this is G. We only need two of the fraction. We're asked to find E, so E has to be in the selection of the two fractions. So we get E over sine the angle E. Pretty simple. And we are given a complete angle and the side opposite the angle. So we have to use that one. 15 meters, which is G over sine the angle G. Now we just put in our values. We don't know what E is. We're trying to find E. So, and I think you should write down when the sine rule and cosine rule are used. So this is E over sine the angle E is 60 degrees equal to G is 15 meters, sine the angle G is 38 degrees. So sine 60 is 0.866. So this is E divided by 0.866. E divided by 0.866. And sine 38. Okay, so this is 15 divided by 50 meters divided by sine 38. Sine 38 is 0.617. So we divide these two over here. So E is equal to 0.8, E divided by 0.866. When you divide 15 by 0.617, it is equal to 24.3. So you have 24.3 meters. And then we cross multiply. 0.866 multiplies 24.3 meters. E is equal to 0.866 multiply 24.3 meters is equal to 21.0404. So the length here is 21.04. meters. Okay, so that's the first condition under which you use the sine rule when you're given the length of one side and the angle opposite it, and you have to and another angle, and you have to find another side. In this case, you're given the lengths of two sides and an angle opposite. You have one angle, and you're asked to find this angle here. So again, we only need two of the fractions. So we have L and we need K. Right? So we say we have L. Some persons put, in this case, when you have to find an angle, they will put the lengths at the bottom and the sine the angle at the top. It doesn't matter, you'll get the same answer. Right? So L over sine L is equal to K over sine K. L is 28.9 centimeters. Sine the angle L. We don't know what the angle L is. And K is 13.4 centimeters over sine is that 25.9, right, degrees. No, I think it's 25.1 degrees. Doesn't matter. Let's use the 25.9 degrees. Okay, so this is 28.9 centimeters divided by sine L, and 20 sine 25.9 is equal to 0.43787. So this is 13.4 divided by 0.437. When you divide there, 29.28.9 cm divided by sine L is equal to, when you divide those two, 13.4 divided by 0.437, you'll get 30.66. 30.66 centimeters. Then you cross multiply. 28.9 centimeters is equal to sine L times 30.66 centimeters. This 30.66 will come over. So you'll have 28.9 centimeters divided by 30.66 centimeters is equal to sine L. When you divide these two, I'm just going to flip it, right? When you divide these two, sine L is equal to 28.9 divided by 30.66. You get 0.943. 0.943. And then to get the angle L, we take over the sine, it becomes sine inverse. How do you get sine inverse on a calculator? You press second function for those persons with sharp calculator, or shift with those persons who have other types of calculators. So we have sine inverse 0.943, and that will give us 70.56 degrees. If we should approximate, it becomes 71 degree. And that's the other condition under which you use the sine rule when you're given the lengths of two sides and one angle, and you're asked to find another angle. Let's look at the cosine rule. When is the cosine rule used? The cosine rule is used when given two sides and an angle between them. Two sides and an angle between them. And you're asked to find another side. Sorry, this should have been 10 centimeters. Two sides and an angle between them. Or when given all three sides in this condition here, and you have to find one angle. Okay? So in this case, how do you write the cosine rule? Let's say we are using this angle here, angle A. The length of the side opposite the given angle must be outside of the equal sign. So we say a square is equal to b squared plus c squared. That's Pythagoras theorem. And the addition will be minus 2, these two, bc cos the angle that we're using, which is the angle A. So here we have this example here. This side is F, this side is G, this side is E. We're given the length of two sides and the angle between them. We want to find the length G. We want to calculate the length F. We have E and G. So what do? F squared must be on the outside. Has to be on the outside because this is the length we're trying to find and this is the angle we're using. So F squared is equal to E squared plus G squared minus 2EG cos F, the angle F. So this is our cosine rule for this. Let's solve. F squared is equal to E is 13 centimeters square plus G is 10 centimeters square minus 2, E is 13 centimeters, G is 10 centimeters. Cos the angle F is 40 degrees. When we square 13, we get 169 centimeters square plus square 10, you get 100 centimeters square minus 2 times 13, which is 26, and 26 times 10 is 206. All right, 260. It's 260 centimeters square times cos 40. Cos 40 is 0.766. Right, so these two can be added. All right, these two are connected by multiplication, so we can't subtract these two. So these two can be added. We get 269 centimeters square minus 26. No, we have to multiply. So we subtract 0.766 times our 260. And we get 199.16. So this will be 199.16 centimeters square. Then we subtract the two. So 269 minus 199 will be 69. 69.84. Let me just put it in the calculator to make sure that I'm correct. 199.16 is 69.84. So you have 69.84 centimeters square. Then we bring over this square here. So F is equal to the root of 69.84 centimeters square. F is equal to 8.36 centimeters. So this side here is 8.36 centimeters. Okay, I need to do another example of this, or maybe I can show you. If you have a triangle, and you can try this here. If you have a triangle and the angle that you're given, right? The angle you're given is greater than 90. Let's say it's 98 or 120 or 140 or whatever it is, right? And you're given these two lengths. 9 and 9 and 12 meters. This is A, B, C. All right, you can solve this, and you're asked to find this length here. Find the length A. When you cos, like how we cos this number here, this 40 here, when you cos that 98, which is greater than 90, you'll get a negative answer. So this negative 2 multiplies that, this negative 206, let's use 260, multiplies that negative, let me see what negative 98 will, cos 98 will be negative 0.139. So when you multiply this here by the negative 0.139, you'll get a positive answer. So rather than subtracting here, you will have to, because a negative times a negative is a positive, you will have to add, right? And when you add and then you square root. So you try that example. So I'm running out of time on my video. Okay, final example, and then we do one of the past paper question, is when you're given all three sides and you're asked to find one angle. So let's say we're asked to find this angle here. All right, B will be out here. This is A, this is C. So our trigonometric, our cosine rule will start with B square is equal to A square plus C square minus 2AC cos the angle B, which we're trying to find. B is 20.8 centimeters, meters, that has to be squared. A is 9.3 meters, that has to be squared, plus C is 14.5 meters, that has to be squared, minus 2 times 9.3 meters times 14.5 meters cos the angle B. All right, so let's start squaring these numbers. 20.8 squared gives us 432.64 meters square. 9.3 squared gives us 86.49 cm square plus 14.5 square gives us 210.25 minus 2 times 9.3 times 14.5 gives us 269.7 meters square cos the angle B. We don't know what it is. That's what we're trying to find. So we can add, we have to. This is 32.64 meters square. We have to add these two, so you'll get 296 point, that is 296.74 meters square minus 269.7 meters square cos. Remember, these two cannot be subtracted because this is connected to this cos by a multiplication. It's like trying to if you had 9 minus 2x. You can't subtract these two because they're unlike terms. So what will have to be done, this has to go over the equal sign. So we'll have 432.64 meters square minus 296.74 meters square is equal to minus, I maintain that minus over there, minus 269.7 meters square cos the angle B. When we subtract over here, 432.64 minus that 296.74. You get 135.9 meters square equal to minus 269.7 meters square cos the angle B. This comes over, it's connected to this by multiplication. When it comes over, it becomes division. So 135.9 meters divided by minus 269 square is equal to cos B. When we divide 135.9 divided by 269 minus 269.7, our answer is minus 0.504 equal to cos B. So cos B, I've switched it around, right? B, when you bring over that cos, is equal to cos inverse minus 0.504. And so we have shift cos, or second function cos, minus 0.504. And our answer is 120.3 degrees. So the angle here is 120.3 degrees. That's what we find it now. So there is your cosine. Here's your cosine rule. Okay. Our next topic will be, we're supposed to solve this question here quickly, and then we go on to bearing. So let me read it quickly. The diagram below, not drawn to scale, shows 3 points R, S, and F on an horizontal ground. FT is a vertical tower of height 25 meters. The angle of elevation of the top of the tower, T from R, is 27. T from R, that will be this angle here, 27 degrees. R is due east of F and S is due south of F. Okay, so the question asks, first of all, sketch separate diagrams to represent the three triangles. All right, so let's do that quickly. This one is easy. This is with January 2013, question 10, and you can go looking for questions like these there. So let's sketch our three different diagrams using this spot up here. So we already have T. We already have FTR, this one here. This length is 25 meters. This angle here is 27. Next one will be, this one is a right angle triangle. All of them are right angle triangle. No, is that so? If this is due south of F, yeah, this is a right angle triangle. Doesn't look like it, but it is. So let's do the one at the bottom. You have F here, S, which is due south. This is 43.3 meters. This is R again. And then finally, the one at the top. All right, this is S, this is T, and this is F. This is the triangle this side, where we have this being 43.3 meters, and this is 25 meters. No angle was given there. So let's attempt to solve the questions now. This is show by calculation that RF is equal to 49.1. RF. From R to F. So that would be this distance here. We have that triangle at the top there. And on right angle triangles, we know that the trigonometrical ratios are used and Pythagoras theorem. So this is the opposite side. This is the adjacent. So we have to use the ratio, the tan ratio, to find that angle, right? Well, you already know how to do this here, so I'm not going to do this. Tan theta is equal to opposite over adjacent. So tan 27 degrees is equal to the opposite side is common r over t, common t. When you find tan 27 and you put r as 25, you'll solve that. Next question is calculate SR. Calculate SR to one decimal place. SR. How do you get SR? Oh, when you find this side here. Oh, okay. I figured it out. When you find this length here, which is FRF, right? When you find this length here, whatever it is, you have to use the Pythagoras theorem. If you find this length, you use Pythagoras theorem, and you get that. This is the hypotenuse, this is the other two sides. Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So you can get that easily. Then the final question, calculate the angle of elevation of the top of the tower, T from S. T from S. So you want this angle here, T from S. Okay, so again we have to use a tan to get this angle here. This is the opposite side, OPP. This is the adjacent side. And if you want to get this angle, we have to use the trig ratio again. Tan theta is equal to opposite over adjacent. So tan theta is equal to the opposite side is S, so small s over small t. Tan theta is equal to S is 25 meters divided by 43.3 meters. When you divide that, 25 divided by 43.3, we get 0.577. So tan theta is equal to 0.577. So theta is equal to now tan inverse 0.577. I think that we did this earlier, it should be 40 degrees, I'm not sure. So shift tan 0.577 is 29.985 degrees, which is 30 degrees. There you go. So this is our video on sine rule, cosine rule. The next video will be on bearings.